Hey, what's up everybody? Welcome back to another Layer by Layer. In today's tutorial, we're going to take a look at the Guitar Tuner project. This is a collaboration project with Liz Clark of Blitz City DIY. This uses the Adafruit PyPortal, and what we've done is we created this two-piece enclosure slash stand, and the Guitar Tuner has this nice touchscreen with some graphics. So you can tap on any of the pegs and get some audio so you can tune your guitar. I really like the way that this is housing the Adafruit PyPortal vertically. So this is good for this type of project where you need to have your screen propped up vertically. And it's using hardware screws. These are nylon M25 sized hardware. In the back, you can see there's plenty of extra room. It's fully open. And the frame is actually printed flat like this, and it prints up. No support material. There's a little bit of some angles, but it prints out pretty good. They're printed with all perimeters, no infill, so it's pretty quick print, but also pretty sturdy because it's all perimeter. And then the PCB plate itself is printed flat. There's some tabs here on the side that line up nicely with the mounting holes on the side of the frame. And then there's some hex nuts here that are securing those screws together. There's also some extra bits in the center here. We have a little spot for the speaker so that we have a nice mounted speaker here that just press fits into that little cavity. We have plenty of room for extra components. There are some more standoffs that are right up here that are housing, that are elevating the PyPortal PCB. And then we have this bezel here that just keeps the screen nice and kind of flush here. So that's how that's going. And then we have some dimples in the bottom here for some feet. Those are pretty neat. Those print nicely without any supports. And then there's some gap here so that we can have some wires pass through if we ever want to use those stemma ports for extra components. So so it's really cool. I like the way it's driven in Fusion 360. We have full control over all of the different angles using just one sketch. So I want to show you guys how you can create this type of enclosure stand with just one sketch, and it's really cool to kind of change it and modify it and really change it a lot by just modifying a few different parameters. So let's go ahead and jump it into Fusion 360 and take a look at designing it. So here in Fusion 360, I got a blank document. Let's go ahead and save it. So I'll go ahead and save this out as like a arcade cabinet for PyPortal. Why not? I will save it in my little layer by layer folder here. Gotta have a little bit of structure in my work. And then what I'm gonna do is I'm gonna bring in the Adafruit PyPortal a little bit later. I kind of want to flesh out the sketches before I bring it in. So the first thing we can do is, after of course saving your document, we can create a new component. The way I'm thinking about it is I want to have a component that houses all of the things that pertain to the enclosure. So I'll have two things. I'll have a frame and I'll have a PCB mount, or let's just call it a plate. So for this, I'm going to call it enclosure. And then I'll go ahead and create my two components. So I'll have a frame. And then I want to make sure that the enclosure is selected, because now when I create a new component, it'll be inside of enclosure and not inside of frame. So you kind of want to think about that when you're creating your components. Where is it going? And what component am I currently in? So right now I'm in the enclosure component and I want to create a plate. So I'll name it that. So there we go. Now you'll notice that my bottom timeline here is nothing's in there, because as I switch between the components, that's where it's going to isolate those features in my timeline. And then if I go to the root, you'll see all three of them here. Cool. All right. Next thing I want to do is highlight the enclosure bit, and then talk about so for me personally, I like to design with no grid, but back before, I really liked designing with the layout grid enabled, just so that I can get an idea of where I should model, where I am in space. It's kind of jarring to just see a blank canvas, so this is, I think, a good way to kind of visualize where you're going to model in space, because that's kind of important. Another thing is that this is the default view. If you look at your viewing cube, you can see that we have the front, we have the right, and whenever I click the home button, that's basically your default view. Of course, you can change your default view by going under here, named views, and you can right click on it or something and say I forget how to use it. I don't use it much, but there is a way to update your view so that you can see it differently. But I just like to design with the default view in mind. So in this case, I want to have the screen up here, and then back here will be all the stuff in the back. Even still, a lot of the times I'll design something, and then I don't think about the default view, and every time I open the design, it's facing the wrong way or just backwards. So it's a nice little thing to keep thinking about, where am I designing this in space in my default view. So now with that out of the way, let's go ahead and draw a sketch. So for this, it's all really about the profile, the side of our frame, and that's kind of like the main shape that we need to draw. So just think about an arcade cabinet and how that side panel is really like the defining shape. So for this design, we are going to use the side plane to sketch on. Another thing that I really like to do is to really use the origin. Sometimes I have a symmetrical design and everything is going to be centered around the origin, but for this one, this is more of like the bottom corner of my enclosure. So what I'll do is I'll start drawing some lines, and I'm going to draw it like this. I'm going to start from the center, work my way out, get something up. Let's go across. And then we're going to have this sort of a slanted view, a slanted line. And then I'll have a straight edge going back down again. Okay, so now I have that. So the next things I want to do is to start to define some diameters, some dimensions. And I'll start with the bottom. So let's bring this out. 45 is okay. I'm going to worry about scale a little bit later because I think it's okay to kind of figure out that later. This will, let's say 60. And then for this, I really want to define the degrees of which it's sitting at. So from here to here, I want to say 70 degrees. And then this line itself, I want to define that one with a hard number, let's say 10 for now. And now you can see that it's pretty much defined. One of the things I want to do is I actually want to make these two lines perpendicular with each other. So the way to do that is I kind of have to look at my constraints here, and you'll notice that there's already a perpendicular constraint here. So if I want these two lines to be perpendicular, then I got to really move that one. And it's really easy to do. You can just select this little icon and hit delete, and now I can add some angles to this if I need to. So what I'll do is I'll select this line and this line, holding down shift so I can select both. And then right up here in the top menu of the sketch environment, I can hit perpendicular, and that way it'll make it nice and perpendicular. So these two lines are now perpendicular. And why did I do that? It's just, you don't have to do it. I just like the way that looks. I think when I'm printing, it just looks better in my opinion. So all these shapes are preferences. You don't even have to have this one here. This can go straight down if you wanted to. But I think that's okay. All right, so now that I have that kind of main thing set out, I need to kind of think about how am I going to make the plate. So the plate, I do want it to be parallel with this line here that has that angle. So what I'll do is I'll make another line in the middle here somewhere. And thankfully, Fusion by default added this parallel constraint. But let's say I didn't have it. Let's say I don't have it. So I have it like this. So what I can do is I can just say I want to select this line and this line, and I want them to be parallel with each other. Right up here, you can select parallel, and Fusion will hopefully do it. Hey, I did it. I had to hit it twice. So now I have these lines that will always be parallel with each other. So now what I want to do is I want to create some perpendicular lines that will connect to this line. So I'll start from one of these points here. And then as I roll over, hopefully I can get that. Yep, I can get that perpendicular icon there. It kind of snaps there too, so I'll just click that to accept that. And then I'll do it for the bottom side here. So click on the point, roll over this edge here. You can see as I roll over, I'll get different types of automatic constraints, which is handy. I don't want a horizontal constraint. I want a perpendicular constraint. So there it is, and it snaps there to it. Excellent. That looks good. The next thing is I need to kind of define how deep I want this to go. So one cool way is I can actually kind of do two things. I need to define some distance between these two lines that are parallel. And I also want to define some distance between this up here and this one down here. So essentially what I want to do is I want to make this line always be in the middle of this line. So one really easy way to do that is to grab a line, and as I roll over this line, you're going to see that triangle come up, and that triangle is a midpoint constraint. So as I click on that, that's always going to be in the center. And then if I start to roll over, you'll see that this crosshair shows up, and that crosshair is actually the midpoint of that line. And that's kind of what I want. So I'll click on that, and then all I have to do is select this line and either this one or this one, let's say this one, and then say I need these to be perpendicular. And now it'll always going to be straight. So no matter, watch as I drag this top line, the bottom line follows it too. That's because it's following that it's obeying those constraints where it's always being in the midpoint of it, because that's how we set it up. One thing I want to do is remove this line, not remove it, but make it a construction line so that it no longer creates this separation here where there's two profile entities. So if I select the line and hit X on my keyboard, or just select this construction icon here, it will make it so that it does not split my entity, my shape. So now it's just being used as a construction line, as a point of reference. So that's cool. And now I can define how much depth I want, so I can actually give this line a dimension. You want to be careful when you apply the dimension. I want the dimension to be parallel. So as I roll over, you can see how it's changing from going to parallel, going straight up and down, or not. So I'm going this way. So let's just give it a number like 12 for now. And then I can also give a dimension to this right here. Again, we want to make sure it's parallel with our line and not horizontal or vertical, but parallel like that. And there's nothing special other than just moving the mouse in a different location to get that parallel or perpendicular. So now I can apply a number here. Let's say 40 for now. Okay. Next thing I want to do is I actually need to create another line with this. It's basically somewhere in the middle here. This is going to define the thickness of our plate, because what we're kind of fleshing out is our plate and our frame all within this one sketch. And again, we're in the enclosure component, so it has its own sketch, and then we can reuse those inside these guys. So let's go ahead and create this line. I got my line tool. I'll do something over here, and then I want it to be perpendicular with this line here. So now that is there. I don't need to define a length of this dimension. I just need to define how far away do you want to be from this line, and then I can apply something like 1.5 millimeters, which happens to be my favorite value for thicknesses. By the way, while I have that, let's go ahead and open our user parameter window. So I got that open, and then I can create something called thickness, and I'll go ahead and name it 1.5 and hit OK. And now I can go back into this 1.5 sketch dimension and just say thickness, and I'm going to reuse that quite a bit. So now that I have that, I want to define a width. That's the next thing I want to define. So here's our sketch. We're still inside the enclosure component, and we have like the side profile of our little arcade cabinet style thing. So what I'll do is I'll bring up our user parameters, create a new thing, and call it width. Maybe frame width or something. Box width. I'm not sure what to call it, but width is a good thing. So I'll give it a number. Let's say 50 for now. Hit OK. And then what I'm going to do is I need to activate the component that I want to create. So what do I want to create first? I'm probably going to create the frame first. So when I select the frame, my sketch gets ghosted. It kind of gives you a UI. It's a UX thing where it's like, okay, just so you know, that sketch is grayed out because it is not inside of the frame component. It is outside of it. Well, that's okay, but we're going to use it anyway. So now that we have our frame active, I'll go ahead and select this, hit extrude. I actually want to select all of the profiles in that, like the main thing. And then what I do is I want to bring this out. I want to change the direction from one side to symmetric. And that way I get symmetric on going on both sides. But what I want to do is to change the extent from distance, or actually no, leave that alone. I want to change the measurement from half length to the whole length. So now 26 is the whole length and not being doubled up like the half length is. So the half length says this half is 30 and this half is 30. So it's really 60. But if I change the measurement from half length to full length, this will now be 30. Is actually half of it would be like, I guess, 15. And so what I want to do here is we just created our width, our box width. So I'll just type in width, and then I'll just select it from here. It kind of auto completes it for me. And now I have the width. That's a user parameter here. So whenever I change that user parameter, it'll always change up here. Operation is set to new body. That's all good. There's no taper angle here. So I'll hit OK. All right, that's looking cool. So the next thing I want to do is start to create the frame itself. And the way I did it was, instead of having to draw some more sketches or do some offsets, there's a really easy way to do it with the shell command. The shell command is a super powerful way to create a shell. And here's what we can do. Without even creating the shell first, I'm just going to select this surface, this top surface, and this bottom surface. I also want to select this surface on the side here. And really what we're saying is those surfaces there, that's what we want to create a shell from. So now that I have those selected, I can just click on the shell button. And then for this inside thickness input here, I'm going to just say thickness. Hit enter. You can see how powerful that shell is, where it's shelling out everything I need except these 1, 2, 3 sides here. So that's a really neat way to do this, because it's just one feature as opposed to like several features to create that, maybe even a sketch. So if you look at our timeline, it's only just that extrude and that shell, and that's looking good. All right, so the next thing I'm going to do is create that plate. So let's go ahead and activate that component. Hit plate. Again, our sketch is still open. It's still ghosted, but that's fine because we can still use it. So I'm going to use this one piece here, this one little profile entity. I'm in the plate component activated, and I'll hit E on my keyboard for extrude. Start to extrude this out. We're going to do some similar things where we change the direction from one side to symmetric, and then we'll change the measurement from half length to the whole length. And then we're going to do a little bit of math. So we do want the width, but the width is now, because our shell is doing an inside type, we're kind of crashing into our frame. So all we need to do is we need to say we want to subtract the thickness times 2, because we have a thickness on this side, which is 1.5 millimeters, and a thickness on this side, which is 1.5 millimeters. So what we've done is we've said box width minus thickness times 2. Now the reason why it's in parentheses is because that's how math works. You need to have it in parentheses. That's a good explanation, right? We're going to leave the taper angle alone, and we're going to leave the operation to new body. And that's looking pretty good. So I'll hit OK. So now we've created our kind of main objects. I'm going to go out of the plate and go into the main document here, so that way we can see everything in all its glory. And another thing I really like to do that's really powerful is the sketch. If I want to tweak the sketch, a lot of the times what I will do is I'll have to double click on the sketch. When we do that, our timeline goes back in time before we've done any work, any extrusions and stuff. And that's kind of hard visually to tell how I want to tweak it. So instead of jumping into the sketch, we can do something a lot better. We can open up the sketch in the browser, right click on it, and say show dimensions. I use this all the time now. For sketches where I am still figuring things out, I will always right click on that sketch and say show dimensions. Right now it's set to high dimensions because I just showed it. So let me do it again, show dimensions. This is really powerful because now what I can do is I can say, I want to change that 40 to 50. And I can see that change instantly, visually, without having to jump in or think about how it used to look like, because that's just the way an editing sketch works. It'll just bring you back in time. But if you do a show sketch, you can edit your sketch in the current time or wherever you are in your timeline, which is pretty neat. So at this point, I'm just looking at it and going, yeah, that looks good. You would change up the numbers here, and it's going to affect it nicely. Let's say I want this to go a little bit taller, not 660, but 60. We can do that, or we can increase the height here to 70, increase the depth here to 50. And then at some point, it's going to be really, really nice to be able to change the degrees here. Let's say you want this to be 65. You can push it back. Maybe go even lower to 50. And you can see here you really want to be careful with your values as you tweak them. The other values will need to be tweaked as well. Let's say we want to make this go taller. That's 220. And you can just keep playing around with these values until you get a fit that matches your application, whatever you're trying to do. So this could make a really good Stream Deck type thing. So that's cool. Now it's starting to look really skimpy on the width. So if I want to change the width, I'm going to go into my user parameter window, and then I'll change that 50 to like, let's say 70. And it's starting to white out there. And it's instantly changing, which is great because we don't have that much stuff in the timeline yet. So it's able to quickly update, which is super cool. And I have full control over everything here because I'm just driving everything with one sketch. That's pretty cool. Even the thickness could be changed as well. Let's say we want to go even thicker, go to 3. You can see everything, including the plate. Anything that has that user parameter will update. I'll bring it back down to 1.5. So that's really cool the way it changes like that. All right, so now that we have that, we need to create some mounting holes for our PyPortal. Normally what I would do is I would import the PyPortal, and then I would project the mounting holes onto some existing geometry. What I found in practice is that's okay, but a lot of the times it's better if you don't do that, because then you're not creating this linking where if something happens to the PyPortal, then it's going to lose that reference point. So I'm just going to create some holes in here. So what I'll do is I need to activate the plate, because that's where I'm going to create the mounting holes, so we can secure a PyPortal to the plate, not the frame yet, the plate. So I got the plate. Now I need to figure out where am I going to draw it. I'm going to draw it right on this surface. So I have that surface selected, and then I can draw right onto it. When I click that sketch button, you can see that my grid now is lined up flat or at an angle with the angle of the plate, because the plate's already in that angle that we've defined with the sketch. So now that I have that, I'm going to create 4 holes, or maybe just 1 hole, maybe 4 holes, yeah. So yeah, so let's do 3.5 for that. Create another hole over here. It's really a circle, not a hole. One over here. And then one of the things I like to do is to just use a line to connect these 2 holes together. And then what I'll do is I want this line to be horizontal like that. So I just applied that. Now I have this. And then I need to create another set of these guys. So I'll use some more circles here. Let's say 3.5. Over here, 3.5. And then again, I'm going to use a line to connect these 2. This will be horizontal, like that. And then what I want to do is I want to create another line that connects this line to this line. And now I can see that that's not straight, so I'll click on that line and then say I want it to be vertical, like that. Cool. I could also come in here and say I want these 2 lines to be equal, so why not just use another line and connect these like that, and then select that line, make it horizontal or vertical. So now I'm creating that. So now as I move this, it's becoming symmetrical like that. So that's really neat. Right, so now I actually need to tell these lines, I need to assign them some dimensions. And the dimensions, I'm just bringing these out because I really like to have them outside of the circle. So that's helpful. I like to position my sketch dimensions in a way where I can access them and I don't have to like zoom in too hard. So now that I have these set up, I need to open up the PyPortal itself. Luckily I have it. This is a good segue into getting our files, our 3D models. Every Adafruit product has a Learn Guide. In the download section of that Learn Guide, you will find data sheets, 3D models, and Eagle CAD models if we haven't made a 3D model yet. So you can get a really fast way, get access to those files. They're all free to download in whatever file format. We tend to upload in step so that folks that have different CAD packages can use it. So here's the 3D model. So anyway, I'm going to come in here and use my measurement tool to figure out what are the distances between these holes. So the hotkey for that is I for inspect. So I'll select this line, or this circle, and then this circle. And then what we want to use is the distance here. You can see there's a minimum distance, but we want to use the whole distance here, which is 83.185 millimeters. So we'll jump back over to the other tab, and then I say that this one needs to be 85.185. You can see already that, okay, our enclosure needs to change. PyPortal is way bigger than that. I think I'm doing it wrong. Yeah, I need to have the PyPortal vertically. So this value is actually needs to be this line here, the vertical line. And you can see, yeah, that needs to be changed too. So I'm going to do that next. So let's bring our inspection measurement tool back up. We'll say, what is this hole? How much distance is away from this hole? And that's 59.182 millimeters. So let's bring that, let's update this, paste that in there. And now we're looking at a real one-to-one representation of this. And then I can start to figure out, how do I get this to be in the center? Well, our origin is still here, and it is the absolute center of this whole piece. So I can start to make a line. I'll start from the center, that way I know it's in the middle. And then I get this guy over here, which is also in the middle. And then I can say I want this to be vertical, so I'll apply that. And then I can give it a number. I kind of don't want to do that though, because I'm thinking that if I ever change that, I'll have to keep changing this number. So why not make it, why not, instead of doing this line, I'm like on the fly thinking here. And then instead of doing that, I think I could just bring in this line, bring a projection of this line. That way, if that ever gets updated, which it will, we can have some rules set so that this is always a certain distance away from this edge. So we can do that. I actually want to do this edge here because I'm having a thought that if I bring this edge in here, then I can apply some midpoint constraints to say I always want the PyPortal to be in the middle of our plate. So I just did that by creating that line and applying those midpoint constraints there. I just want this line to be horizontal all the time, nice and straight. So I'll click that, and now I got that. And then I probably want to do, as you can see, I can't really change it yet because I definitely need to update the plate. So we need to get out of here for a second, and we're going to start to tweak the plate so that so that the plate encompasses those mounting holes, because right now they don't. So now that we have it open, I'm going to go into our main component so I can get a better visual look, and my sketches aren't no longer ghosted. So now I can give some more values to this thing. So I need to give this a little bit more length, more tallness. So let's go with 90. And then this right here, the 60, which is defining the length of the plate. I'll make this 70. And then just keep playing with it until I get those mounting holes covered. Let's go with 90. That's looking way better. So as you can see, it's getting there. The whole goal here is to get everything to be symmetric. So we got these guys are midpoint constraint. Now I need to create a midpoint constraint up here. So let's go ahead and jump back into the plate. Fusion. And then we can apply, let's go ahead and hide that sketch, the main sketch, because it's kind of in my way. So I will now be able to create a line in, I'm in there. So line, I want to say in the center of that with the center of that. And then I can start moving that around, and I'll say, hey, you know what? I want to make that horizontal. So it's always straight up and down. So now you can start to see that now it is centered with this line and centered with that line. And this whole set of holes is has these fixed numbers because those are going to be our mounting holes for the PyPortal. So what I want to do now is just kind of select these lines and start to create construction lines so that they don't intersect, so they don't split my my holes when I'm using them. So I'm just selecting them and hitting the X key on my keyboard, which is the short key for creating a construction line. So that's cool. So now all I can do is select those holes. Let's hit finish sketch. Select that hole, all 4 of them, and then we're going to pretty much cut them, extrude inwards like that. Let's change the distance to all. or maybe not all, because it looks like it wants to cut that down. Let's say to object and select the back of our plate, and then that way if our plate ever changes thickness, it'll go through all of that. So hit OK. Okay, here we are. We got our sketch here. I'm going to hide it for a second, and then bring back our main sketch, and then activate the whole component. All right, so at this point we have our mounting holes, our plate, and everything's kind of situated. Now what we need to do is to import our PyPortal and start to see how it looks like in place. So one thing, if you are going to use multiple electronics, I would recommend creating a new component and calling it electronics or parts or something like that. That way you can have it nicely grouped inside of a parts folder. So I'll bring in that enclosure here, or I'll bring in the PyPortal now, right click, insert it into current drawing. It's going to bring it in at this orientation. And what I like to do is I like to reorient it using these handlers here and just reposition it to as closely as I can and then apply a joint. So it's a little bit difficult to see because the way the Fusion brings it in, it's all blue and I can't tell what's what for now. I think that's the USB port. So I want that USB port to be actually lined up, facing up. And then I can, again, oh look, bringing it kind of got rid of that weird highlight view that I don't like. Makes it challenging to see. So I'm just moving it around because if I hit OK before moving it around, then you're going to have to capture the position. That's just an extra thing that you don't need in your timeline, because you can just do all the work here before you hit OK. It's a little bit slow here though, because I am streaming or recording this. But that looks good. I'm going to hit OK. Nothing's here other than the import. So now at this point, I will select all of the thing, like the whole document. I probably want to hide that sketch. And now what we can do is apply the joint to any of these holes, really. We just need one hole. So whichever one you pick, just make sure that it's lined up with one. Like I don't want to have this tab be joined with this hole because that doesn't make sense. So let's go ahead and bring up our joint tool up here under Assemble. It's J is the hotkey, or you can just click that icon. I want this mounting tab here, this hole, with this hole here on the plate. Let's see how Fusion snaps it down in there. Now, this is cool. You have some offsets, your joint alignment. You can add some offsets here, and we do want to have some offsets. I'm actually going to not have it flush with this plate. I need to elevate it away from the plate because there's quite a bit of components on the back there and that wouldn't work out. And I'm going to use hardware standoffs to actually elevate this guy. And my standoffs will have a fixed number of 10 millimeters in length. So I can apply that there. Now, this is still in joint mode. Fusion doesn't, it won't render out all the components until after you've hit OK. So if I hit OK, because of the way the model has joints associated to this model, everything gets fixed once you hit OK. So now we have this floating PyPortal, but that's because we've added that offset. But at this point, what we can do is bring out the main sketch and start to manipulate it and fine tune it to where we really like. So whether we want more room or more elevation or less elevation, it's pretty simple to do so now. I've been meaning to try out a 45-degree viewing angle. So I think this will kind of crash into it. So let's see what happens there. If I change this 50 to 45, it won't let me. It's like, hey, there's going to be some problems there. So I'm probably going to have to make this wider, this taller, and now I can go down to 45 and see what goes on there. Yeah, you can see here. I can add some more depth here by changing this value from 10 to maybe 20, and it brings it more in. Maybe not so much, maybe just 15. You can start to really massage and fine tune it. I kind of want to bring in, I want to make the plate taller because it looks like those holes are pretty close to the edge there. So all I got to do is just change up this 90. Let's make it 100. And now it's taller, depending on how you want it, right? And that's looking definitely different. Yeah, I don't know if I like it. like better how it was. Maybe change this 45 to 60. And that's looking more like an arcade cabinet, which is what my original idea was. Yeah, you can just keep playing around with these numbers until you get something that really, really matches what you want. So that's looking pretty good. I mean, at this point, we can create those mounting tabs and all this stuff, but really I just wanted to create the kind of the bare essential of creating our arcade style stand for our PyPortal. But that's really the main gist that I want to do. Now you can start adding all the features that you need to now that the main stuff is done. Again, we did use some user parameters here. We got thickness. We want to change it up to 3. Everything gets updated here. So now all the plates and the frame are both thicker. And then we can change the width. Maybe we want to go a little bit wider. That's looking okay too. And all our holes should be the same since we use the measurement tool there. But that's pretty much how I set up the enclosure for the PyTuner. It's only just a handful of features in the timeline, which I like. That means you can modify the sketches here and everything gets updated really quick, which is pretty cool. So that's really it. I hope this is useful. If you guys have any questions on any of the stuff I covered, please leave them in the comments. And also I will share this file. Let me save it real quick, saving. I will share this file so you guys can download it, take a look at it. And don't forget all of the Adafruit models are available on our GitHub repository right here, github.com/Adafruit, Adafruit CAD parts. And that's where we're posting all of our parts, so you can get those. Or you can get the Eagle CAD files from the respected learn guides for each product. They all have their own learn guides. So that's really neat. That's good to get. Don't forget, this is a real project. You can actually make this. It's done in CircuitPython. Huge shout out to Liz Clark for creating this project, writing the code for the project. I just designed the little cases and stuff. So thank you guys so much for watching. I hope you enjoyed this one. Remember to stay safe and healthy. But until next time, I'll see you next time. Bye, everybody.